our powerful sun. Our sun gives off tons of energy, which helps keep plants and animals alive on the earth. It's just like a power plant generating heat and light for the entire solar system through nuclear reactions in its core. The sun is composed of a few different gases, but the two main gases that we find in the sun are hydrogen and helium. Even though the sun is made up of only a few gases, it actually takes up more than 99% of the material in our solar system. Compared to the Earth, the sun is huge. The sun has a diameter of 1.4 million kilometers, or 870,000 miles. That means we could line up over 100 Earths across the middle of the sun. If we hollowed out the sun, we could dump about 1 million Earths inside of it. The sun actually has a lot of mass, or the amount of matter that is inside of it. It has 330,000 times the mass of our Earth, making the sun's gravity 28 times stronger than ours. Gravity prevents the planets, asteroids, and comets, and other space debris from flying off out into space. It's a good thing. In the same ways that we move around the sun is moving too. The sun revolves around the center of the Milky Way. Even though the sun is traveling very fast at about 220 kilometers per second, it still takes about 230 million years to complete one revolution around the Milky Way galaxy. The sun is also rotating on its axis. Because the sun is made up of very hot gases called plasma, the equator of the sun actually moves faster than at the poles of the sun. The rotation speed at the equator is about 25 Earth days, while the rotation near the poles is about 35 Earth days. The sun is made up of 6 different layers. The innermost layer is called the core. The core is where the sun produces its energy by turning 2 hydrogen atoms into 1 helium atom. This process is called nuclear fusion, and it creates a lot of heat and energy. The temperatures in the core are around 15 million degrees Celsius, which is really what allows this fusion to take place. The heat and energy moves out into the next layer of the sun called the radiative zone. The energy particles can take millions of years to pass through this zone because the particles are so densely packed together. They bump into each other and send it back and forth until finally it reaches the next layer. The next layer is called the convective zone, and in this layer, energy rises when it's hot, cools down, and sinks back down. Those are called convection currents. The next layer is called the photosphere, and this is the layer that we actually can see and consider to be the surface of the sun. The temperature here is about 5,000 to 6,000 degrees Celsius, so it's still pretty hot. Once the energy reaches the photosphere, it only takes about 8 minutes for that light to reach the Earth in the form of heat and light. The photosphere is also where we see things like sunspots, which are cooler, dark areas on the sun's surface. We also see explosions of gas called solar flares and arching explosions called solar prominences. All of these objects are a result of the sun's magnetic field lines becoming twisted together. Above the photosphere is one of the atmospheric layers of the sun, called the chromosphere. It's actually a really thin layer and can only be seen during a total eclipse of the sun. The outermost layer of the sun varies in size. It can be bigger or smaller, just depending on how much energy is coming out at the time. But it's called the corona, and the corona is actually really hot. It can be several million degrees Celsius there. This layer also is only seen during a total eclipse of the sun. The sun is the only star in our solar system, and without the light and heat that the sun provides us, life would not exist here as we know it. It is very important for our survival here on the Earth. It's a good thing that our sun is powerful.